All right, folks, thanks for coming out. So you are at lightning fast deployment of your Rails-backed JavaScript app. Hopefully you're in the right place. My name is Luke. Luke Mealy. I live in Manhattan in New York City. Got a couple of little girls who are learning Ruby and JavaScript using Codecademy and Kids Ruby. And I have a company called Yap that I co-founded. We're one of these kind of hybrid product and consulting companies. And when I'm not doing dad stuff or coding, I really love to play beach volleyball and have recently taken up parkour. So Yap Labs is the consulting side of our business. We do Ember.js consulting and training based out of New York and Seattle. If that's interesting, happy to talk with you about that. So by way of introducing this topic, I want to tell you a story. And it's a story of when deployments were driving me crazy. Kind of like tear my hair out crazy. We had an app, and the app consisted, was pretty straightforward for a modern app. It was a Rails app that had a home page. It had your terms and conditions page. You can't have a site without that. It had a JavaScript app, which in this case was an Ember app, but you can substitute any kind of rich JavaScript MVC app that style you'd like for the purposes of this talk. And then it, of course, had a JSON API. And so this was kind of the bullet points, but in terms of the amount of code, the complexity, and how much time that it took working on it, it was more like this. Right? We had a lot of work on the JavaScript app, a bunch more in the JSON API, and the rest of the site was pretty trivial. But in terms of deployments, every time I made a change and wanted to deploy it, we would package everything up and deploy it. And so I have a question for you folks. Hopefully everybody's in the room has worked with Rails. How long does it take to deploy a Rails app? I'm going to do a show of hands, and by the end, I hope everybody will have their will have their hands up. And so please start by raising your hand if your Rails app is deployed in less than 30 seconds. Okay, how about good, awesome one? I want to talk with you later. How about less than 1 minute? Cool, a few folks. Less than 3 minutes. Bunch more, less than 5 minutes. Keep your hands up, even if you were in the early group. Less than 5 minutes. Okay, so we're probably at a majority now. Less than 10 minutes. Keep your hands up. Okay, and less than 20 minutes. I hope that's everybody in the room. Please, mercy. Okay, cool. So I think the answer is it takes at least a few minutes to deploy a Rails app, unless you're one of an exceptional few folks in the audience. And I get it. There's a lot of, there's files to transfer. There's dependencies to install. Most modern Rails apps, that I run into, that we create, have a lot of gem dependencies. It takes some time to boot the app with all those dependencies and just with your app code. And so that's fine, except for I was going days just working on the JavaScript app. Right? I was just making changes to JavaScript, and every time I wanted to deploy, I was waiting about 5 minutes in our case to just deploy static JavaScript changes. And it really made me want to throw something across the room. Like, why was I doing this to myself? And it wasn't just me that I was annoying. I was also annoying our users, because in most Rails deployment scenarios, there can be some hiccups in each deploy. And so let's talk a little bit about this kind of hiccups in deployments and zero downtime deploys. So if your Rails app takes several seconds to boot, which is probably about average, obviously it can't serve requests during that time. And so under high load, in most architectures, requesters are just going to be queued, waiting for the app to be ready to handle requests. And then once it's boots up, it's going to start handling those requests and eventually flush that queue and hopefully catch up to the requests as they're coming in. And so users that are hitting your app during this time may experience, at best case, just a couple of seconds of downtime. At worst case, kind of a feeling like that this site is not responsive. And so it disappoints me that we don't yet have a kind of conventional solution for zero downtime deploys. But it kind of makes sense because, by definition, Rails runs inside of other web servers, and this is really a concern kind of at that web server layer. So Heroku, for example, has an experimental solution. Heroku Labs is Heroku's kind of unsupported experimental area of features. And you can run Heroku Labs enable preboot, which will start up new servers or dynos with your new code, wait 3 minutes to give your Rails app plenty of time to boot, and then switch traffic over. If you're using Puma or Unicorn, there are facilities to restart one worker at a time or groups of workers by sending signals to the master process. HA Proxy is a tool that I've used in the past to kind of split traffic, give yourself time to boot up another set of servers. HA Proxy is nice because you can do health checks against those new servers and say, am I ready to deploy? And Passenger also has some solutions around this. In terms of kind of the full scope of zero downtime stuff, it gets more complicated when you talk about database migrations and what's safe and what's not safe for these types of deployments. And I'm happy to chat about that with anybody later, but that's out of scope for this particular talk. What I do want to drill into a little bit is issues with static assets and zero downtime deploys, because that's the thing that was kind of at the heart of what I was doing, is really dealing with these static JavaScript assets. And I think that these issues aren't discussed often, so I want to drill down kind of at a detailed level and talk about them here. So when a browser makes an initial request to your server to load your rich JavaScript app, it's loading the index.html file. And by index.html, I'm going to refer to the HTML file that's like bootstrapping your JavaScript app. It's the thing that has a little bit of code to fire things up, and it pulls in the right JavaScript and CSS assets. So the request comes into your servers. Your server responds with the HTML file with the text/HTML MIME type. And typically, your asset files, the JavaScript and CSS that are going to be referenced here, are going to be fingerprinted, right? So we do take a hash of the contents of the JavaScript file. We set it as we include that hash in the file name, and we then are able to set far features expires headers on those files so that when the file changes, we don't have to worry about cache expiry or anything. We've just got a new file that's going to come through as if the browser's never seen it before. And so in this case, our HTML file might contain something like assets/app-abc123.js, where abc123 is this fingerprint we're talking about. And so the browser takes that HTML, parses the page. A short time later, makes a request for app-abc123. Server says, here you go, some text JavaScript. Browser parses that, boots up the app, all is well. Hopefully this is very clear to everybody who's in the room. What's maybe less clear, unless you've thought about it in detail, is that during deployments, this idea can break down a little bit. And so imagine that we've got our deployment, and we've got two kind of sets of servers. The top set that we're looking at here on the screen is the existing code. And the bottom set is the new code that you're deploying. And in this case, there's a change to the JavaScript file, so there's a new fingerprinted file name there. So when our initial request for our page comes in, we will go to the old code because we haven't yet switched traffic over to the new deploy. And just like in our first example, it's going to come back with the index file referencing app-abc123.js. Now, what if in that moment, as the page is being parsed before this request comes back, we then switch traffic over to pointing to the new server? Well, the request is going to come in for app-abc123.js. The new server gets the request and says, I don't know what you're talking about. I don't have a JavaScript file with that name. And so it says 404, not found. And this is a challenging problem to address because of a few reasons. One is, most simply, if I at this point now hit refresh in the browser, of course everything works fine. Right? Because now both of those requests are going to the new server, and the world is good. It can be further kind of shadowed, this issue, because if you are serving your assets up through an asset host, a CDN, you might have some of your edge nodes might have that old page cached, that old JavaScript cached, in which case those nodes will return it just fine. And so to know that you're totally impervious to this might be a little bit fuzzy, and also to be able to reproduce it reliably is a challenging thing to do. But in short, to avoid these hiccups, both the old versions of your assets and the new versions have to be available for at least a few minutes during your deployment in order to make this zero downtime approach really work well on the static asset front. And so this was one of the things I was thinking about during these many 5-minute deploys where I was wishing that I had a solution. And so in thinking about that, I said, well, we could figure out how to do this on our app servers, kind of keep the old versions of the JavaScript and the new versions together, or we could move the assets elsewhere. And the idea of moving the assets elsewhere really appealed to me because that meant if they weren't on my Rails servers, then maybe I could avoid doing Rails deploys when I just had static asset changes. So I started to sketch out an idea. We've got our Rails server at the top, and we had this separate static asset server at the bottom. Let's deploy our Rails app code to the Rails servers, our JavaScript, CSS, and images to these static asset servers, and then we would deploy our index file. Where would we deploy our index file? And so I started to think about, well, what is the index file? It is kind of this thing that bridges the two. What are the requirements around it? What do we know about it? And the HTML file points to fingerprinted JavaScript and CSS, but it's not fingerprinted itself. That's obviously important because it needs to be at a consistent location for browsers to load. It contains JavaScript URLs and code to boot the JavaScript app and to load CSS and such in the right order. It's a good place to provide environment-specific configuration to JavaScript. Maybe you have some differences between dev and stage and production. One thing that I knew was key because I had struggled with it is that when you serve this HTML off of the same domain as your API, life is way simpler with respect to CORS and cross-origin security issues. And finally, if you wanted to be able to deploy changes quickly to your users, caching on this particular page should be minimal to none so that you can pretty instantly switch over. So my conclusion from thinking about this is that the HTML page ideally should be managed and thought about as part of your static asset deployment process, but it should be served off of your Rails server. And as importantly, it should be served off your Rails server without requiring a Rails reboot or redeploying the entire Rails app. And so we were able to start to refine the sketch and say, OK, our Rails server is going to be serving up our API requests, our kind of traditional dynamic Rails pages, as well as the HTML for a JavaScript app, and our static asset servers going to be serving up the JavaScript, CSS, and images. And so that means we need to somehow deploy our HTML up to the Rails server without a full reboot. And so how can we do this? Well, the most obvious thing to me was, well, take a HTML file and put it on the file system of each Rails server. And this has a few things that aren't great about it. You could probably make this work in some configurations. In many deployment environments, disk is ephemeral, and so relying on on copying some things up might not be a great idea. It's also a little bit weird to mix files deployed from a particular Git SHA with files deployed from somewhere else, kind of in the same file system. And so we said, well, what if there's something that we could all see and talk to? Well, what about uploading to S3? So then all the Rails servers can see S3, read from it, be able to serve up that HTML. And this could kind of work, but reading from S3 is a little bit slow. And we wanted this page to be fast. Obviously, no JavaScript or CSS is going to start being loaded until this page is loaded in the browser. And so the faster we can get this page to the user, the better. And so then we said, well, what about Redis? Redis is persistent. It's fast. For us, it was already in our environment. We liked this idea a lot. We decided to dig in. This is not as you'll see, this is not the only way to do it. It's totally possible to use other systems besides Redis, but Redis kind of fit the bill for us and works quite well, as you'll see. So the general idea was we're going to deploy into Redis and then serve out of Redis via a Rails controller. So here's the simplest possible kind of deploy code that we had. It's a rake task, and we're going to generate our HTML for the current assets. And that's kind of an exercise for your build tooling, which we'll talk about in a little bit later. And then once we have this HTML, we're actually going to set it as a Redis key value store. So the HTML is the value, and the key would be something well-known like JSApp::index, for example. And this is a Redis connection that's connecting directly to your target deployment environment. So that's staging or production. Once it's there in Redis, our controller, again, the most simplest version, is get the value out of Redis, render text HTML. Now, when I first looked at this code or wrote this code, I said, is that going to be served up with the right MIME type? It seems a little strange. And it turns out that yes, if you do render text and some string, Rails serves that up with text/HTML if you don't specify. So it's a little, I think, a little bit of a confusing API, but it does what we want. So we can now continue to refine this approach. We know we're deploying, when we need to deploy Rails app code, we're doing a deployment to our Rails server. When we're deploying JavaScript, CSS, and images, we're deploying to the static asset server. And then we're deploying HTML by connecting to Redis and deploying into it. And we can make things a little bit nicer by dropping CloudFront right in front of, by using S3 as our static asset server, and then dropping CloudFront instead of in front of S3. So for very little effort and very little money, we've got now CDN distribution for our static assets. Now, there's a few things about this deployment to S3 in terms of making it fast. Getting a file list from S3 can be somewhat expensive, particularly the more files that you have. And so the approach that we took was to generate a manifest file of our current assets and store the copy of that manifest on S3. So we're basically going to read the remote manifest, compare it to our local manifest, and know we only need to deploy what's different. And so this means that if I make one line of JavaScript change, it's just the file that's concatenated into that needs to get updated, and not all of my images in CSS as we're doing our assets deployed to S3. Now, purging has been on our to-do list for this architecture for quite a while, right? After the deploy is successfully completed, you can, in theory, remove stuff from S3. We had never really got around to that, mostly because it's so incredibly cheap to store these small files on S3. So still on our to-do list. I would probably not recommend you prioritizing it too high for yourself. The code for this S3 sync is here at this link. We'll make these slides available. You don't have to worry about copying it down. This repo is open source and contains a lot of the code that we're looking at today. And it's the actual code that we use for our production environments. So once you start thinking about this architecture, it paves the way to do something a little bit more fundamental with your rich JavaScript app and your Rails app, which is to tease them apart into separate repositories. And why would you want to do that? Well, one of the reasons is think about tagging a deployed version of your code. Since you've got these independent deploy processes, it makes sense to be able to tag a JavaScript deploy separate from a Rails deploy because they really are now independent of each other. And I find also that thinking of your JavaScript app as a separate, independent client of your API works really well, kind of puts it on the same level as a native app, for example, if maybe you've got an iPhone app that communicates to your API as well. It also opens up the realm of possibility to having a lot of flexibility with what kind of build tools you want to use with your JavaScript app. You may choose to use sprockets in your separate standalone repo, or you may choose to use Grunt, Gulp, Broccoli, Brunch, you name it. There's obviously a lot of innovation and creativity happening around build tools in the JavaScript environment. And my guess would be that we're going to see faster innovation and iteration in the JavaScript environment built for building JavaScript apps than we will in the Ruby environment for building JavaScript apps. So we've now got an approach that works pretty well, but I think the question is it worth doing the work to set this in place? Like, how fast is this in the real world? And so I took one of our apps, and this was not a scientific benchmark, so consider it directional. And our build took about 6.5 seconds. This particular app was using Rake Pipeline as a build tool for the JavaScript side. Our transferring assets to S3 using this differential approach was about a second, and then uploading HTML into Redis was about 2.5 seconds. And so instead of a 5-minute deploy, we're now able to deploy our JavaScript apps in under 10 seconds. So just by that was a big win, and stopped me from wanting to throw things across the office. But I think that in any kind of architectural choices like this, you learn if this is a good idea or not over time. right? Based on how does this architecture respond to changes? What kind of possibilities does it enable? So I want to talk a little bit about the kind of emergent behavior that we've seen around now that we've had this in production for a while. The first thing is the idea of preview. And so this is an actual command line session for deploying an app. In this case, it's YAP Prefs, which is our kind of account settings app. We first run rake dist. This is the build. And with the build completes, in this case, as we saw on the pie chart before, about 6 seconds or so. And it says, OK, to deploy these assets to S3, run rake deploy assets with this, what we call a manifest ID, this B35B. So what's a manifest ID? We talked earlier about fingerprinting assets, and we talked about creating a manifest file. So what we do also is we fingerprint the manifest file. So we take a hash of the contents of that manifest file, and we say, OK, that is the manifest ID for this deploy. And it's kind of unique identifier as it's going through the deploy process. And so we run rake deploy assets, which does the differential upload to S3. And it's going to show us what it uploads. That's going to spit out, OK, I've uploaded these 4 files, JS, CSS, 2 YAML files for the manifest. These are 2 copies of the same thing. One has a file name with the ID, and one just is, hey, I am the latest. And it's going to then tell us the next command to run is deploy generate index for this manifest ID. And what this is going to do is going to connect to Redis and set this at a key named for the manifest ID. So in the previous simplistic example we looked at, it was just updating JS app index. Now it's updating a key at prefs, in this case, prefs index B35B, named for the manifest ID. And why is this awesome? Well, this command line tool can now tell us, hey, to preview this asset change, go ahead and take a look at your site with the query param manifest ID equals B35, et cetera. And what this is going to do is it's going to pull the new HTML file from Redis, going to show which is loading up the new JavaScript. It's connecting to the production API, so you're able to smoke test this in production. Everything is working just as your user will see it, except for your users don't see it yet. So if you screwed something up, you've got a chance before kind of pulling the trigger and switching it live to go. And then finally, one more command to kind of activate that Redis key and make it the current key. And so what does this code look like? It's actually not that much more complicated than what we saw before. We invoke our rake task with a manifest ID, generate our HTML file, and then instead of setting JS app index, we'll set a JS app key based on the manifest name, a Redis key based on the manifest name, and then spit out something to give the developer the URL to take a look at to preview the app. On the server side, we're going to add one more Redis request to the mix. If there's a manifest ID param, then we'll just use that. If it's blank, then we'll go and we'll connect to a current key, grab the manifest ID, then use that to serve up the current version of the site, of this index file. So that's has been pretty powerful and is a super useful tool that we use in almost every single deploy. The developer is going to just do a quick smoke test and say, yes, everything looks good before they flip the switch. The next interesting aspect that this kind of enabled is around dynamic HTML rewriting. And so what we realized is that as HTML was passing through from Redis through the controller back to the browser, we had the opportunity to make adjustments if we wanted to. And one category of adjustment that we ended up making, and you see in this example, is injecting some information about the current user. Now, obviously, in a Rails controller, we know typically who the current user is, right? Most apps will have a current user method available to any controller that they can grab. In contrast, when you're booting up a JavaScript MVC app, at that point, most apps don't know who the current user is, and mostly there is some XHR request that's involved in figuring out, is this user logged in, and if so, what is their role in the system? And during that time, the user is sitting there waiting, right? The JavaScript app is just kind of, maybe it's rendering a loading spinner for the user or something. But it's a little bit annoying, and it also makes the boot process for your JavaScript app more complicated. So we said, well, what if the app could have, at boot time, have access to this information? And so what we're doing here is in the controller action at the top, between the time we get the HTML out of Redis and render it, we're going to inject current user information. We're going to grab the current user and then use our active model serializer to convert it to JSON, escape it, and stick it into the head tag. And you'll notice that the method that we're using to add this to the HTML, you might find a little crude. And certainly, when I first started doing this, I said, OK, well, we'll use Nokogiri. We'll parse the HTML, and then we'll insert a node, and then we'll convert that back to text. And it turns out that really what we're doing is so simple that as fast as Nokogiri is, and it's pretty fast for an XML or HTML parser, it is not faster than string manipulation and string indexing. And so in this case, we're just looking at where's the end of the head tag or the beginning of the head tag. Inject this meta tag in there. And this works great. Some other use cases for this same approach might be injecting CSRF tokens. If you need to interact with Rails forms from your JavaScript app, including dynamic analytics params. We had a case where the JavaScript app was kind of a goal page for a Google Analytics kind of flow, and we needed to set some certain JavaScript only in some conditions. So this was a nice way to do that. If you're using feature flags through something like the excellent rollout gem, it's great. That's available throughout Rails, but how do you make it available inside of your JavaScript app also? This is a nice solution to be able to kind of inject variables along those lines. Another pretty awesome thing that we've been able to do using this approach is doing A/B testing within our JavaScript app. And we've experimented with two different kinds. One is kind of setting some flags based on which A bucket the user ends up in, A or B. This is pretty similar to what we just described. And then the second is serving up wholly different HTML based on the A/B bucket. And I'll take you through each of those. So this is using the split gem, which, if you haven't seen, is a great A/B test tool for Ruby frameworks, Ruby web frameworks. It has a Rails integration that gives us the A/B test method, which you see on line 11 there. And so we're doing some injection into our HTML where we're saying if the user is part of the show walkthrough experiment, then we're going to inject a script tag that just sets a global variable. And then our JavaScript app, as it boots and is running, can consult that global variable to decide whether to show the walkthrough that you're doing some testing on. And then later, elsewhere in your app, you would indicate that the goal was achieved, that the user signed up or published or whatever it is that was kind of the goal for your A/B test. And so this was great. This is excellent for the kinds of A/B tests where both paths are supported by a given incarnation of your JavaScript app. We had another case, though, where this was right around the time of the iOS 7 released, and there was, if you recall, there was a lot of excitement around flat design. And so we did a redesign of our JavaScript app. We weren't immune to the hype. But as we got near completion, we started to wonder, well, we're going to release this. How do we know that this is any better than our existing site? Is this going to improve our metrics or hurt them? And we wanted to try to get some confidence one way or the other. So we said, well, we've been developing this in a branch, and we already know that we can easily preview different versions of our JavaScript app since we had this preview mechanism in place. Could we use this for A/B testing also? And so it turns out that we were able to just update our deploy scripts to be able to deploy from a branch into an experiment kind of Redis key, and then use the same A/B test mechanism to determine for the new design experiment, should the user use the current manifest or the experimental manifest. Once we made that decision, we then got the appropriate manifest ID from Redis, got the HTML, rendered it, and the users either saw our old app or the new flat design app. Turns out, flat design, about 9% better, so good news. So this is suitable for changes where your development's happening in a branch and you want to A/B between the branches. Not a common scenario, but when it's useful, it was great to see how this approach supported that architecture. One more possibility that I didn't cover here, but you can imagine how this might work, is around doing rollback. So what if every time that we did this deploy and updated our HTML in Redis, we pushed into a Redis list and said, hey, so-and-so user deployed such and such manifest ID at this time, and then we were able to have a rig task that reads that list and lets you roll back to any particular version. Hopefully, at this point, you can see how straightforward that kind of thing would be as well. So with that, I want to say thank you to my colleagues at Yap Labs who helped to create this, Chris Selden, Stefan Penner, and Ray Cohen. And while we were working on this, we had heard some rumors about some Square engineers using a similar approach at Square. So we took some inspiration from those rumors as well. And so thank you, nameless Square engineers, or if anybody's here, love to chat with you about it. We've got some time for questions, and so I want to open it up to all of you. Question in the middle. All right, cool. Thank you all so much. Appreciate it. Enjoy the rest of the conference.